Good evening, everyone. Welcome, a very warm welcome to LSE, to everyone here in the room. My name is Patrick Wallis. I'm one of the professors in the Department of Economic History and its current head of department. And it's my great pleasure to introduce this public lecture by Professor Eric Schneider on the trends and determinants of global child malnutrition. What can we learn from history? Before we get to business, just a couple of practicalities. This is a hybrid event, which is why we're starting on time. Forgive me, those in the room. It will also mean that it's going to be recorded and be made available later, so keep that in mind when you engage in questions afterwards. We do have a Twitter hashtag, which is, I think, LSE Echist Child Growth. So that's going to trend. But if you would like to tweet, please do. And obviously, if you do want to engage with social media, we'd encourage you to, but with a silent mobile phone, please. And just to say, after the lecture's finished, there will be time for questions. We will be taking questions from audience online, as well as from people in the room. So if you wish to do that online, then you need to simply type in your question onto the online system and it will be passed to me and I will voice your question to Eric. But that is all a matter for later. So this evening is, I think, a particular treat because this is a special moment. This is Eric's inaugural lecture. It celebrates his promotion to being a full professor. And this is the most senior, the highest stage in an academic career at LSE and in any university. So promotion to a chair is not something we decide in the department. It's something that's in the gift of a university-wide committee of professors who call on experts from around the world to evaluate the research and work of someone being considered for promotion. And the test they use is a really simple one. They want to know whether this is someone whose work is world-leading. It's kind of a high bar. It's a hard challenge to meet. It means that what they're doing is changing the frontier of our knowledge. It means that people from around the world look at their work for ideas, for findings, for methods that they themselves will be able to build on. So this is a point that is the culmination of years, decades of work. And so it's a really wonderful moment when someone's promoted. And it's a really wonderful moment when we get to bring them here to hear from them about what it is that they've been doing. I think you all know that the work that Eric's produced over the last 15 years or so since he started, which is a very short amount of time, more than justifies his position here at the front of the room. Economic history is a really broad discipline, but at its core are a set of questions about the conditions of human existence, of wealth and poverty, of hunger and abundance, and how and why these have changed over time. And the most fundamental of our conditions is physical. It's our biological capabilities and capacities, our health. And Eric's set out to help us understand human health in the past, to measure human growth, disease, inequality in those most fundamental moments of life when so much is defined, the period before birth, the period of early childhood. And this stuff is not easy. It doesn't sound easy, right? It's really amazingly challenging work to engage with in the past. It's hard in the present. It's been very much harder in the past. So we're going to hear from Eric. He's going to take us on a journey, I think, about child malnutrition, one of the issues he's going to be working on. But before I pass over to him, I just want to say thank you to Eric for everything you've done with us, for us, over the last years that you've been a member of LSE as a researcher, but also it's worth saying as an outstanding teacher and an outstanding citizen. And I also want to thank you for all that you're going to do. And of course, no doublespeak there. And of course, for the lecture. So Eric, please, over to you.
Thanks very much. Oh, well, thank you all for being here. And Patrick, thank you for that introduction. It's very kind. Before I get started, I want to maybe take a half second for reflection as well. Research is often a kind of lonely process, but none of us get here without the help of a lot of different people. And so, I want to thank my family, my wife, Debbie, all of my supervisors from my PhD, my many mentors who are in the room today, my colleagues and my friends for supporting me throughout this process and helping me reach where I am today. So thank you all. So we're here today to talk about, or to learn about global child malnutrition, how it's changed, and what were its causes. And so really when I'm talking about child malnutrition, I'm going to talk about child stunting. And child stunting is just referring to children who are too short for their age. So if we look at these children from Guatemala, if they were as tall as children in healthy populations, we would expect them to kind of reach this yellow line. But we see that they're a bit shorter, and that's an indication of their stunting. So currently in the world today, there are 148 million children who are stunted. It's about 22% of children. And if you look at the geography of stunting around the world, you can see it's most prevalent in sub-Saharan Africa and India and in Southeast Asia. And so, yeah, that's the snapshot of what we see today. So why does this matter, though? What are the consequences of child stunting? Well, it's kind of two things. One, it reflects poor health conditions for children in early life, okay, in these growing years. But those poor health conditions also have an effect on those children for the rest of their lives. So these stunted children tend to have poorer health, particularly in old age. And it also affects their human capital, their educational outcomes, and their earnings later on. So this has a real impact on the economy, not just on health, although I think the effect on health is worthy enough of study. And it's this reason that child stunting is a key development indicator, and reducing child stunting has been a part of both the Millennium and the Sustainable Development Goals. Okay. So, but why do we need? I'm a historian. Like, why am I even talking about this? This is all kind of current things. What we know about the historical perspective is that global child stunting has been declining since at least 1985. But the data before 1985 is very sparse. It's very limited. And so partly what I'm going to show you is a huge amount of data that has been collected to fill that gap. And the second part of this is we've had very little data about countries that are currently high-income countries, about their experiences in the past. So we want to know about what was it like 100 years ago in high-income countries. And this is really important because it's part of this historical health transition. So the health transition is the vast improvements in health that have occurred over the past 200 years. Major improvements in life expectancy, adult stature has increased. And so what this allows us to do is connect the experiences of what was going on in the past in these high-income countries to what's going on in low and middle-income countries today, and really make those comparisons salient. So what I want to do for you today is walk you through a number of questions. Okay, so the first question is, what can child growth tell us about health, and how do we measure it? Okay, these kind of classic questions of trying to understand a problem. Then I'll kind of give you a little bit of a sense of how child stunting has changed over time. We'll talk about the causes of child stunting, and then I'll conclude with some lessons from history for the fight against stunting today. All right, so beginning with what child growth can tell us about health and how we measure it. I started with this image here, and this is kind of the typical image that we would think about for a stunted child or a malnourished child. These children are from the global south. They're children of color. These are the people we think about when we think about malnourishment. But I actually don't want to use these children to explain the biology of child health. I want to use these children. Okay? So these are girls in the London Foundling Hospital in the late 19th century. The London Foundling Hospital, although it was called a hospital, was actually an orphanage, and it cared for illegitimate children. Okay? So I want to talk about one particular boy and give you a sense of his experience. I'm going to call him William. For privacy reasons, I've changed his name, although not his mother's name, because his name isn't connected to his parents. So William's mother was named Eliza Davis, and she was 21 years old when she gave birth to William. And she worked as a domestic servant in Harlington, which is actually a village right next to Heathrow Airport. You can see it here on the map. Well outside London in this period. This is the 1890s. William's father, John Primrose, was a groom, and he had disappeared a few months after Eliza became pregnant, so he'd abandoned her. And so we can track Eliza and William's movements over time, and I'm going to use the Booth poverty maps that were digitized here at LSE to do that. So just to help you get oriented here, we have Regent's Park here, Hyde Park here, and here we're sitting at LSE, okay? So shortly before giving birth, Eliza was living at the Kilburn Maternity Home, a place where unwed mothers could stay and receive limited care before and after their babies were born. She gave birth to William on the 29th of April, 1892 at the Queen Charlotte Hospital. And at that time, he weighed 7 pounds, 6 ounces, so 3.3 kilograms. After William was born, Eliza spent a couple of weeks recovering at the Queen Charlotte Hospital. And then she seems to have moved back in with her parents, who lived in Red Lion Passage, which is just off Red Lion Square, literally 10 minutes walk from here, okay? Just north of Holborn Station. And on the 3rd of March, 1893, when William was 10 months old, Eliza applied to the Foundling Hospital to give up William, okay? We don't really know why she did this. Perhaps the kind of difficulty of raising a child and working at the same time became too much for her. Or it may be that she was trying to escape the shame of being an illegitimate mother, which was, really problematic at that time for women. But she did apply to the Foundling Hospital. The Foundling Hospital did an investigation of her and her case, which is why we know the information that I'm telling you today. And William was admitted to the Foundling Hospital a few weeks later. Upon admission, William was weighed and examined by the Foundling Hospital's medical officer, and he weighed 17 pounds, so 7.7 kilograms. And the way it worked in the Foundling Hospital is once the children were admitted, they actually they were kind of fostered out with mothers in the countryside. And so William was fostered with Emma Walter in East Peckham in Kent. She had 2 other children herself, and her husband, George, was an agricultural laborer. Sorry, East Peckham is between Tunbridge Wells and Maidstone, if you have an idea of where that is. And so William lived with them until he was about 5. And on the 4th of May, 1897, he returned to the Foundling Hospital main site in central London. This is a picture from the 18th century, but it gives you a sense of the kind of grandeur of this building. This is right next to the Brunswick Center, where Coram Fields are today. And again, William was examined. He weighed 33 pounds, 15 kilograms, and he measured 3'3" tall. Okay? So that's the kind of story of William's kind of movements in the first 5 years of his life. And we can track his growth by plotting his weight at various ages to see how he was growing. Now look, there's a bit of a sleight of hand here because I'm going to be talking about weight here because that's what I have data for. But for the rest of the talk, it'll be focusing on height. But it's similar enough that we can get by with that. But looking at this growth curve, it's really difficult to tell, is William growing in a healthy way or is he not, right? And so in order to understand whether he is growing in whether this is a healthy growth trajectory, we need to compare William's growth against a kind of standard of growth, okay? And so here I'm showing you the mean height from the WHO growth standard. And so this is meant to be a normative standard for how healthy children should grow. So what that means is that in a healthy population, the average child should be on this line at each age. Okay, the average child, not every child, the average child. Okay. And we can get a sense then that he's maybe starting a bit close to the mean and then falling behind, but it's kind of difficult to get a precise sense of what's going on. We can help that a little bit by plotting the standard deviations of the distribution of the growth standard, okay? So we have one standard deviation, the mean, and then standard deviations below the mean. That one didn't turn out, sorry. It's in the screen, but not on that screen. And so it makes very clear that William is falling behind. So he starts out close to the mean, he falls back to maybe about near -2 standard deviations, and then he catches up a little bit again. And so what we do then is we transform William's growth into what are called Z-scores, okay? And so this is just telling us how many Z-scores is William from the mean of that healthy population. And so again, he starts out close to the mean. Sorry, if in a healthy population, the average child would just be 0 all the time, okay? And so what we can see is that William is falling behind in the first year of his life, and then he catches up a little bit between ages 1 and 5. So what explains this growth trajectory that William had? So if we start with his prenatal health, so what was going on before he was born, that might affect his birth weight. Well, we know, for instance, that William's mother, Eliza, was working outside of London, right? So she was not exposed to kind of the terrible conditions of central London in this period, right? She probably had better quality food. She wasn't exposed to the same kind of atmospheric pollution that someone living in central London would be. And we know that she also was involved in in the Queen Charlotte Hospital and in the Kilburn maternity home. So perhaps she was getting some prenatal care, limited prenatal care. So maybe that's a kind of rosy picture at that point. If we look at the conditions in infancy, what's going on when William's really falling behind the standard here, you can see there's a big difference. So in this period, William's living in central London, right, in Red Lion Passage. We know that his mother breastfed him for 6 months, but he was weaned before he entered the foundling hospital. And so what that means is that he was being exposed to contaminated milk and food. The milk in London at this period was horrific, right? There's a paper about it called White Poison. It was adulterated and very problematic, full of bacteria. So living for 10 months in central London took a toll on his health. He probably had chronic diarrheal infections. There's high levels of atmospheric pollution. The Booth map classifies his street as being middle class, but around the corner, as in many places in London, there's a very, very working class place. So he wasn't far from poverty. And central London at this point was extremely crowded. So there's probably a lot of possibilities for disease to spread. Okay, so now if we think about the time that William was in the countryside, living in East Peckham, and you can think this is actually quite an improvement, okay, in many ways. So being in the countryside, he had probably better access to good quality food. His father was his foster father was an agricultural laborer, could probably bring home some food along with that. And the food would be fresh. So if he were drinking milk, it would be from the cow down the street, not from some kind of, industrialized, disgusting process. There's also going to be relatively low levels of atmospheric pollution. It's a lot less crowded. We know that he contracted whooping cough while he was in the countryside, but he avoided measles. So maybe there's a little bit of a good side to the disease environment as well. So that's kind of William's story. But what we really want to know is what's going on for the average child, or what's going on in the population, not what is happening to one individual. And so in this graph, I've plotted William again in red. All the gray lines are all the trajectories of growth for all the children in the foundling hospital that we can observe, okay? And then the blue line is the average, okay, the average weight for age Z-score. And you can see that the average child is following a very similar trajectory to William. They start out pretty close to where they should be, they fall behind, and then they catch up a little bit while they're in the countryside. And this pattern is actually extremely common. We see this in most unhealthy populations. So this is growth faltering in India in 2005. And you can see the same kind of pattern. Again, now I'm switching to height, but we can, with some caveats, we can do that. But you can see that in India, children start out fairly close to the mean, not as close as in London, but they fall behind in the first 2 years of their life. Okay? And that's this common pattern of growth faltering. So I think what we learn from this is that child growth is really sensitive to nutritional and disease conditions. And this is the balance of nutritional intake and energy expended on being alive, growing, and fighting infectious disease. And nutritional quality matters as well. The protein, the calories that you're getting, the micronutrients. And we've also seen that there's this really common pattern of growth faltering in the first 2 years of life. And so I think that, the child growth really tells us a lot about the health conditions that are facing a population. So that's kind of what child growth, how child growth works. But now we need an indicator of trying to understand, how child growth is experienced in populations. And this is what child stunting allows us to look at. Okay, so I'll walk you through what child stunting is precisely. So here, I'm showing you the distribution of girls, the height distribution of girls age 6 in the WHO standard. Okay, so this is the distribution of healthy 6-year-old girls. Okay, and notice that there are short girls and there are tall girls, and there's quite a variation in height among healthy children. Okay, 70 to 80% of height variation within populations is driven by genetics. Okay, so that's clear in how this is working. So what stunting is that we kind of define, in some ways, an arbitrary threshold under which we think growth is a bit abnormal. And the threshold that we set is 2 standard deviations below the mean of the reference. Okay? And so basically, children who are below that line are considered to be stunted. So note, even in a healthy population, we would expect about 2% of children to be stunted. Okay? And those children are healthy, right? So it's not a perfect indicator in that sense. It's not telling us who's at risk, on an individual level basis. But at a population level, it reveals a lot. Okay? And that's especially true when we start comparing populations. Okay? So this is the distribution of height for 6-year-old girls in the Foundling Hospital in the 1890s. So William's sisters, if we call them that, right? Institutional sisters. And you can see that the stunting rate is much higher. There's a larger share of the distribution below that threshold. So instead of 2%, we have 30% of girls being stunted in that period. Okay? Now, what does stunting decline look like? I'm going to talk a lot about how stunting has declined, where it declined, all sorts of things like that. But let me show you what it looked like in London. Okay? And I'll show you again using 6-year-old girls as a reference. So if we look at girls in 1906, in London, these are school girls. Their stunting rate is 43%. Note that they're actually doing worse than the children in the Foundling Hospital. If we follow that up with a study in 1931 in Edmonton, a suburb of London, we can see that the stunting rate has fallen to 14%. By 1950, it's fallen to 6.6%. And if we look at the Millennium Cohort study, which isn't London specific, but is a representative sample of the UK, the stunting rate has fallen even further to 3.4%. Okay? So stunting decline is a shift in the distribution of heights. You can see the mean is shifting upward. Often also the variance may become smaller. And that allows basically stunting to be eradicated. Okay? So what does child stunting mean? It's a proxy for the extent of growth faltering in a population. We always compute it relative to the WHO standard or reference, and this allows us to make comparisons over time and across populations. And I think it's proper to think of this as an absolute measure of deprivation, not a relative measure. If we were to compare average heights of populations, we might get something more relative, but stunting is an absolute measure of deprivation. Okay? Kind of like the $1-a-day poverty line, something like that. Okay, so we've talked about how we measure child growth, what factors influence child growth. Now let's look at how child growth has changed over time. And as I mentioned in the introduction, very little was known about the history of child stunting before the research I'm going to show you. The focus of the global health research has been on the recent past, from the maybe 1980s, 90s to the present. And there are very few studies that have explored stunting before that. We know from evidence in trends in adult height that stunting may have been high in high-income countries in the past, but because we didn't have measures of child stunting, we couldn't really compare with what we're seeing in developing or in low and middle income countries today. And so what I've done and what we've done as a team is we built a team of 40 people to reconstruct child stunting rates into the past. And we focused primarily on the period before 1990, when those current estimates begin. And what that meant was going and finding child growth studies from all over the world and taking the data that they reported and then converting that data into stunting rates. And I want to stop here just for a second to thank all the people who've been involved in this research, because it really has been a huge team effort. I want to particularly thank Juliana Jaramillo and Matthew Purcell, PhD students in our department, who put a huge amount of effort into this project, into the kind of dirty data work. It's been really invaluable. So what do these studies look like? I like this one because it gives you the 3 types of data that we have in one study. Okay? So early on, in the late 19th century, we often get frequency distributions. Okay? So the number of people at given heights. Okay? You actually see the development of statistics in this project. So when the mean and this, well, the mean was invented before, but when the standard deviation is invented, you actually start getting the mean height and standard deviation of height also reported. And then finally, sometimes you would get deciles of a distribution of height. And then you can, assuming that the distribution is normal, you can determine a stunting rate from the deciles of a height distribution. And so this is kind of what we did. We went out, and this is for the UK, and we found every child growth study that we could find and then plotted them up. Okay? And so this is what the kind of history of child stunting looks like in the UK. Now, unfortunately, not all of these studies are nationally representative randomized cluster trials, the things that you would expect from the demographic and health surveys, which are used to track child stunting today. And so we excluded a number of these studies for being non-representative. Okay, so you can see some of these up here. These are for poor law schools that I've studied in other work. So these are very, very poor children whose parents are in the workhouse. So they're not really going to be representative of the average child in London. And then also we have some evidence for upper class children who are also not representative. Okay? But in some ways these are helpful still because they give us bounds, right? We know that like the stunting rate probably wasn't in the 70s and 80s in Britain before in the earlier 19th century, because we see that really poor, London children are not having stunting rates above 60%. So we then exclude these non-representative studies and compute trends based on decadal averages, okay? All based on birth years, okay? And so what you can see is that the stunting rate in Britain was around 40% in the early 20th century and it's fallen, especially in the first couple decades of the 20th century. Right, so what does this look like? Okay, so the blue dots I'm showing you here is the data that existed before our project. So this is the kind of joint malnutrition estimates that are produced by UNICEF, the WHO, and the World Bank. And these red dots then are what we were able to add. So we were able to add a lot of data going back for a lot of countries over time. And so this final historical data set includes 930 historical growth studies, 1,700 historical stunting estimates, because sometimes you would have 2 years reported in the same studies, or 2 countries, or 2 geographic regions. It covers 122 countries. That's over 27,000 kind of mean height by age measurements, i.e. the height of 7-year-old girls. And it reflects measurements for 129 million children. And we add then the modern data into our data so we can kind of connect the past and the present and look at what's going on. And just to give you a sense of the data, what this map is showing you is the first kind of cohort where we observe stunting data. So this kind of teal color here you see for Russia and Canada and the US, the big countries. Those are countries that we observe before 1900. And then the peach color is from 1900 to 1920, and then so forth, as you see. So you can see we're actually covering a really wide range of countries around the world. For some countries, like for Japan and South Korea, we can actually go way far back in time and have a look at what was going on in those countries in the distant past. But even for kind of other low and middle income countries, we can often extend the stunting estimates back to the 50s. And that's interesting, right, to be able to track things a bit farther than we have in the past. So again, rather than presenting trends for 122 countries or trying to show you maps that you wouldn't really be able to follow, I think the easiest way to present this data is in a graph like this. Okay, so on the left-hand side, we have current high-income countries, currently classified as high-income countries. Note that in the past, these countries were much poorer, right? Because we're looking at, I don't need to tell this to historians, but countries were poor in the past. And then on the right-hand side, we have current low and middle-income countries. And the data I'm showing you here is what we had before this project began, right? This is just those joint malnutrition estimates, okay? And what you can see is that there's quite a range of stunting rates. Stunting has been declining over time. You have kind of areas with very low stunting rates and countries with much higher stunting rates. And so that's kind of the starting point for this project. So what I'll do is I'll kind of extend bits of the graph for you and give you maybe a little bit of commentary on them where possible. By the way, so this is for 25 countries. I've selected them because they cover the world, and they're also some of the countries where I'm most reliable that the data quality is good and that the trends are sort of right. Okay. So first off, if we look at these kind of low stunting rate countries, in low, middle, and middle income countries, we find that in the Caribbean and in Argentina, there's very low stunting rates going back to the mid-20th century, which is very surprising because these were very, very poor countries then. So that's a bit of a puzzle. Okay, so this kind of outlier status that they have today is also present in the past. If we extend South Asia back, we can see that there were mostly higher stunting rates in the past. The trend for India is something I can discuss in the questions if you have questions about that. But even in Sri Lanka, we see much higher stunting rates in the past than today. If we look at Southeast Asia and East Asia, again, we see higher stunting rates mostly. In Africa, we have higher stunting rates in the Gambia, kind of a more flat trend in Egypt. And then finally, looking at Guatemala and Peru, you see a very, very strong decline in stunting rates in Peru. All right, so that's the kind of low and middle income country picture. And I think one of the things to highlight is that there's a huge variation in the past as well. This isn't just something that's a product of what's been happening recently. If we look at high income countries in the past, there's a kind of outlier group as well, and it tends to be the kind of European settler colonies and Scandinavia. So the US, Australia, New Zealand, Canada, Norway, Sweden, Denmark. Okay? And they have relatively low stunting rates going back into the past. If we look at Western Europe, we can see there's actually higher stunting rates, right? So in the Netherlands and Britain, we have stunting rates that are actually in some cases higher than they are in India today, right? So on that map that I showed you at the beginning with high stunting rates being above 30%, these countries had high stunting rates in the past. You can also see that there's kind of a different timing of decline across Europe. Okay, so we see declines early in Western Europe, a bit later in Eastern Europe, and a bit later in Southern Europe, where you see Greece there in blue. And finally, if we add in some East Asian countries, so Japan and Korea, we see very, very high stunting rates in the early 20th century in both of these countries. This data is very reliable. The data for Japan is the best data in the entire data set, going back historically. So I'm extremely confident that is correct. And you can see that both of those countries have completely eradicated child stunting across the 20th century, largely after World War II. All right, so that's the kind of pattern of how child stunting has changed over time, and I think there are 4 key takeaways from that. First, stunting rates were high in current high-income countries in the past. Second, that there's a lot of heterogeneity among low and middle-income countries historically and today. I think it's very clear that this stunting decline is a crucial part of the health transition. And it's also clear that even though we can't really get a global figure for child stunting for 1900, it would be far, far higher than the figures that we're working with today. All right, so that's the kind of bit on how child stunting has changed. In this third section, I want to talk a little bit about what are the causes of changes in child stunting. And I want to focus on 5 factors. There are many more than 5. I'm happy to talk about others in the questions, but I think these are some of the most important. And they're also the things that I'm sure are in your brain and maybe you're already questioning about. Okay? So these are population differences in growth potential, okay, in terms of genetic growth potential. GDP per capita growth, nutrition, water, sanitation, and hygiene, it's called WASH, and maternal health, okay? And what I want to do is kind of connect research that's been done and that we're doing as part of this project historically with another contemporary debate. And this is this debate called the Indian enigma, okay? And this enigma is that children in India are more stunted, they're shorter than children in sub-Saharan Africa, despite the fact that Indians are richer, they have lower mortality rates. On many kind of indicators of development, Indian children should be doing better, but they're not, right? And so I'll link it to this modern debate as well. Okay, so this first cause is genetics, okay? And this is not just a kind of academic theory. Panagaria in 2013 wrote an article in the Economic and Political Weekly, which is a really important weekly kind of social science magazine in India, claiming that Indian children were more stunted than African children because they're genetically shorter. And in his article, he has this comparison in his mind. Okay, so we have here on the top the mean heights of adults in the Netherlands, and on the bottom we have the mean heights of men in Japan. And you can see that both of their heights have increased a lot, but there's this persistent gap between them. And so he argues that this proves that there are kind of genetic differences in height. So if we're thinking about how this would affect the comparisons that we're making, it's really about whether or not we can use this one universal standard of growth. Okay, can we use this WHO standard? Do we believe that it's real? And there are 2 fundamental assumptions that are kind of underpinning the use of that standard of reference. The first is that within population, changes in child growth over time are caused by changes in the environment and not changes in gene frequencies, meaning that there's not natural selection, right? So the same population can be compared over time. And the second point is that all populations would experience a similar growth trajectory if children were exposed to similar environmental conditions. And what that means is that there are no significant genetic differences in growth between populations. Okay? And so what I want to try to argue today, and I'm happy to do so more forcefully in the questions if asked, is to argue that these assumptions are justified. Okay? The first one, I think there's no real debate about this, to be honest. It does not seem likely that the kind of increase in stature that we've seen over time could be driven by natural selection. Stulp et al. Do some simulations to test what would be needed to make that work. And in order for the secular increase in height in the Netherlands to be driven by kind of assortative mating, only the tallest 37% of the population could reproduce. Right? And that's not something we observe empirically. So that is not what's going on here. The second point is much more challenging, right? And fundamentally untestable, right? We can't take Japanese children and then, raise them exactly like Dutch people would be raised, right? And also over multiple generations so that we could see what the trajectory would be. But it's also more complex than I think, the average person might think, right? So we now have these massive genome-wide association studies which analyze the association between height and millions of people's genomes, 5 million people's genomes. And what these show is that 21% of the loci in the genome are associated with height. So height is something that is affected by thousands and thousands of genes, not kind of one gene here or one gene there. The most common variants that we see for height have very, very small effects, meaning that they make you a hair taller than you would be otherwise. Okay? And even the variants that are large, and the large variants are 0.5 centimeter, right, which is nothing compared to the gap between Japan and the Netherlands. Those are very rare in the population, right? And they're certainly not kind of uniform across populations when we see that. A caveat with this research is that it's mostly based on Europeans. And so there needs to be more research with African and Asian populations to bring that in. But there are enough Africans and Asians in these studies to know that there's not one gene that's explaining the difference between Japanese and Dutch people. So I think if there are genetic differences in growth between populations, it will be from the cumulative effect of thousands of genes. And that's extremely complex and difficult to understand. It's not a kind of like, oh, this population is tall and this one is short, right? That's not the way that this will work. And the final thing I'd emphasize is that growth is extremely plastic, right? The amount that both the Dutch and the Japanese have increased in height, the same population, is larger than the gap between them, right? So that you have the same population that's 15 centimeters taller today than it was 100 years ago. So it's kind of hard for me for people to take one point in time and say, this is the genetic effect, right? We don't really know that. There's no reason a priori to believe that there should be meaningful differences across populations. And the final point I'll make is that if we're looking at stunting, which is again an absolute measure of deprivation, we can see that Japanese children are no longer stunted, right? And so there's no excuse for Indian children, right? The stunting rate in Japan was just as high as it was in India in the 1970s. There's no reason that India can't eradicate child stunting. And policymakers should focus on that. Okay, so that's the genetic part, maybe a bit defensive. Let's get to some of these other causes. So I'll start with GDP per capita growth. So we think that GDP might affect stunting through several pathways, probably more than I'm going to say here. But one is that GDP makes people richer, and then they can spend more money on health-promoting goods, right? They can, get clean water. They can buy better sanitation. They can invest in medical care. But the second way that GDP might influence things is that higher GDP means higher tax revenues for governments, and then those governments can expand their public health provision. Okay? So it's worth thinking about whether GDP matters. And it's also important because GDP is the most important indicator that governments are working toward, right? It's what they care about, right? So if child stunting could be solved by economic growth, that would be something that would be important to know. And so if we just plot on the y-axis here we have the stunting rate, and on the x-axis we have GDP per capita in log scale, we can see that there's a pretty strong negative relationship between child stunting and GDP per capita growth. So rich countries don't have stunted children. Okay, so maybe that's a rosy perspective. When we unpick this a little bit further, though, we can look at specific countries and the time trend of those countries over decades. And you can see that some countries seem to kind of follow this general trend, where GDP seems to matter. So these are countries like Myanmar, Bangladesh, Sri Lanka, Greece, and Hungary. But there are also a lot of countries that experience really radical declines in child stunting with very little growth, right? So this either means that $1 extra made all the difference in the world, which I think is unlikely, or that GDP doesn't matter that much, right? And I think the fact that you see this same pattern in Liberia, in the Gambia, in Japan and in the UK, all at different levels of GDP, suggests that there's no kind of magic GDP threshold that's going to allow you to just eliminate stunting, right? And then, of course, we also have countries that have lots of GDP growth, but maybe don't actually experience very much stunting decline, okay? So countries like Nigeria and Pakistan, Egypt, and Equatorial Guinea. Equatorial Guinea is a small country, but has experienced an oil boom that has led to a lot of wealth. But, it leads to these questions, those of us who are a bit, skeptical of GDP as an indicator, right? If we take this a bit further, that's kind of just some nice graphs, but Vollmer et al. Actually looked at the effect of GDP growth on child stunting in that joint malnutrition estimate database. And they found that there's no effect of GDP per capita growth on stunting. And I think this shouldn't be surprising to us as historians, right? Because we know in the Industrial Revolution period, average adult stature fell from about 1800 to 1860, right? Even though there was growth for parts of that period. And it was only in the 20th century where GDP started mattering a bit more for stature growth. And so I think what that suggests is that GDP may matter once the benefits of growth begin to outweigh the costs. So things like urbanization, crowding, and pollution, which are very common in many countries that are in their early stages of growth. The interesting thing, though, is that individual income always matters, right? So GDP doesn't seem to matter. But if we look cross-sectionally, richer people always have lower stunting rates. That's true today. It's true in history. There are strong gradients in height in history as well, in Sweden, the UK, and the Netherlands. And I think this reflects the fact that GDP is a bit of a problematic indicator of living standards. It can't really account for inequality and things like that. So all those kind of common critiques of GDP that we sometimes hear. So we've thought about GDP. What if we look at an input to health more directly, nutrition? We know that stunting is affected by malnutrition. Deficiencies in calories and protein lead to growth faltering, and also deficiencies in micronutrients can also affect growth. We know that also that nutritional interventions may help. Children who get animal-based food, like with protein, animal-based protein, have reduced stunting rates, and that dietary diversity also matters a bit. But a kind of meta-analysis of all the nutritional interventions has shown that even if you did every nutritional intervention to the best of its ability, you wouldn't be able to eradicate child stunting. That's the Buta et al. Paper. And the evidence from history is also a bit mixed, and I'll give you two examples. So I'll start out with the UK. You can see the stunting rate is very high in the UK in 1900. And that reflects a poor environment in some ways, but we also know that there are major improvements in nutrition preceding that period. So between 1850 and 1900, there's a big increase in the calories that are available to the population. And Ian sitting here, we know from Ian's work that although there's kind of deficiencies in micronutrients in 1904 when there's a big survey, actually most people had enough calories and protein, right? It doesn't mean that there wasn't nutritional improvement in the early 20th century. There was. There were improvements in protein and also in calories and micronutrients, but it's not a kind of explaining the story, I don't think, right? So that's one case. The other case is India, and it's very well known from research by Deaton and Dries that in the period from 1985 to 2009, that actually the average calories per capita and protein per capita in India actually fell, okay? And in real terms. And that was despite big increases in GDP and, as you can see, some declines in stunting as well. And so there's not a kind of one-to-one necessarily with nutrition and child stunting. So yeah, we have kind of mixed results on nutrition. Moving to water, sanitation, and hygiene, which I'll call WASH. We think that we know that these things would affect child growth, and through a number of pathways. So the first is that poor water and sanitation increases the prevalence of diarrheal diseases. Children with diarrhea aren't able to kind of absorb the nutrients that they're eating, and so it's a disease in one hand, but it also affects their nutritional content. We also know that parasitic worms like hookworm are spread on a fecal-oral pathway, or not fecal-oral, fecal foot actually, but that those also affect child stunting. And we also know that maternal health can be affected by poor sanitary conditions as well. And Spears has argued that poor WASH is the leading cause of child stunting in India. And what he particularly focuses on is open defecation. So this is people kind of pooing out in the open rather than pooing systematically in one place. So open defecation rates are very, very high in India relative to Africa. And Spears argues that this difference can explain the Indian enigma, right, in itself. So it's worth thinking a little bit about how people contract fecal-oral diseases, okay? And there's a nice chart here called the 5Fs chart. So how do you go from feces to a new host, okay? And it goes through kind of 5 Fs. So we have fluids, so water, fields, walking in the fields and getting hookworm or in that way, touching manure that's being used as night soil to fertilize the fields. We have flies landing on poo and then landing on your food, and then you either touch the food or you eat the food. And of course, fingers. Okay, and so there are different interventions that affect each of these things. So if we were to, kind of introduce a clean water intervention, that would close off this pathway, but it's actually not going to close off the others, right? In order to manage the fingers pathway, we need hand washing, and clean water is often a part of that because abundant water is really important for hand washing to be effective. But really, a lot of this comes down to sewerage, right? This is the thing that prevents the feces from getting to any of these other Fs, okay? And it's interesting in the historical research that often it's been found that it's the combination of clean water and sewerage that really matters. This is work by Claudia Golden, who just won the Nobel Prize, and Marcel also. I won't leave off her junior co-author. That would be poor form for me. But it's the combination of those two things together that makes a difference. And so I want to kind of take that knowledge and apply it to this puzzle that we have, that the Caribbean has very, very low stunting rates. And we can see that this is not just true for Cuba and Jamaica, it's true for Puerto Rico, Bermuda, the Dominican Republic, and then all of the kind of Lesser Antilles islands as well. The London School of Hygiene and Tropical Medicine ran a bunch of studies of child growth in the Caribbean in the 1950s and 60s, and that's where this data comes from. So there's a puzzle here. You might think to yourself, well, maybe stunting rates were always low in the Caribbean, right? Because we don't actually see a trend here. We don't see the decline. But that's not the case, because when we observed enslaved children in Trinidad in 1813, the stunting rate is 76%, okay? So there must be a decline sometime in between those two dates. And there's no reason to believe that, Trinidadian enslaved people were worse off, substantially worse off in a way that would mean very high stunting rates and very low stunting rates elsewhere. But this kind of actually does align with some of the other information that we have. So the Caribbean actually experienced a very early mortality transition beginning in the 1920s. Between 1920 and 1950, Jamaican life expectancy rose from 36 to 55. So that's a big change in a relatively short period of time. And Riley argues that this was despite there not being significant improvements in real wages, GDP per capita, nutrition, or public health expenditure. So what made this possible? Well, I think we can explain this through WASH, right? So if we think about Jamaica in the early 20th century, open defecation was very, very common. And what changed is that in 1919, the Rockefeller Foundation arrived and initiated a hookworm eradication campaign. And rather than just kind of giving people medicine to get rid of the hookworms, they were doing some systems thinking, and so they realized that they needed to bring down the open defecation rates. And so what they did is they taught Jamaicans to build improved latrines. And there were thousands of improved latrines built in this period. And you can see that there's a reduction in the prevalence of open defecation, and this also led to a dramatic reduction in diarrheal mortality. And so I think this could plausibly explain the low child stunting rates that we observe in the 1940s in Jamaica. But I don't want to put too much emphasis on WASH either, right? Because stunting decline is not solely about water and sanitation. There's a recent study that shows that water and sanitation intervention are not always effective in low and middle income countries. And that's because you're asking people to fundamentally change some of the most instinctual things they do. Right? How do you go to the bathroom? How do you clean up after yourself? And so that's, there's a great story from Coffey and Spear's book about this. They have a book called Where India Goes, which is about open defecation in India. Very interesting. And they have a story about a woman who has had an improved latrine built for her by the government with a full slab. It even has a water trap to prevent the smell from coming back up. And rather than using it as a latrine, she uses it as a storage closet. And she washes her dishes on the slab because she can wash her dishes there without them getting muddy, where she can't do that in other parts. Right? So they're not actually using these interventions. And historical studies also show some mixed results. And I think really context matters for WASH interventions. where things can be provided publicly, where there's already a kind of ethos of sanitation and hygiene, they may be more effective than where you're having to change minds. Okay, the final, how am I doing? Yeah, the final point I want to talk about is maternal health. We know that maternal health affects the development of fetuses. It's basically the ability of the mother to invest in their offspring's development. So there's a kind of notion of maternal capital. And so where maternal health is poor, children are small at birth. And there's, again, strong evidence to suggest that this may be one of the things that's explaining this Indian enigma, right? So on this graph, the top line there is the kind of mean height for age z-score for sub-Saharan African children, and then the dark line is for Indian children. And you can see that even at birth, there's a sizable gap in where these children start, okay? And that gap actually maintains itself throughout their kind of growth faltering experience. So perhaps it's this maternal health component that's actually explaining the Indian enigma. And so Coffey has dug into this a bit further, and she looked at basically the weights, the BMIs of women in India and Africa. This is around 2005. And what she showed is that women at risk of giving birth in India have an underweight rate of about 42%, whereas only 16.5% of African women are underweight. Underweight is defined in terms of their BMI, so it's below 18.5 BMI. So that's really interesting that there's this big gap. Oh, my screen's gone blank. Oh. There's this big gap in between India and Africa here. But we can extend this to historical periods as well. And unfortunately, I couldn't do this with the data that Sarah has put together. But I can show you what was going on in the US in the kind of turn of the 20th century. And what you can see is that white women have an underweight rate of about 7.5%, and black women have an underweight rate of 4.5%. And from Sarah and Deb Oxley's work looking at London and Paisley near Glasgow, we can imagine that the rates would be similar for London women. I should also note, and kind of British women, let's say. I should also note that these come from prison populations. So these are working class populations. So it's probably an underestimate of the share of the population that's underweight. So there are big differences here in these populations. And we can see that play out in birth weight as well. Okay? So here I'm showing you the distribution of birth weights. This is the population distribution of birth weights in Boston in 1985. And now I'll overlay on that the same kind of Boston 100 years before. Okay, so this is birth weights from a lying-in hospital, in a maternity hospital in Boston at the end of the 19th century. And you can see that those distributions are extremely similar, right? Very, very close. If we then plot the birth weights of Indian children, you can see it's just completely different, right? The mean birth weight is far lower in India, right? And if we look at the differences, you know, the increase in birth weight in Boston over time was about 50 grams, and the difference between Boston today and India is 600 grams, okay? This pattern that I'm showing you for Boston is true for many cities in the US, for Canada, for the UK, for the Netherlands, for Australia and New Zealand. So this is not a kind of, you know, this is a kind of feature of what was going on in these parts of the world. So just some conclusions then about maternal health. There are big differences in maternal health and birth size between, let's say, some low and middle income countries and historical high income countries. And what that means is that maybe improving maternal health was less important for the kind of health transition and for stunting decline in high income countries than it might be for countries, low and middle income countries that have lower or kind of worse maternal health. And this is almost certainly related to gender discrimination, right, in the allocation of household resources. And so that's something that needs to be addressed. Okay, so I've given you a whirlwind tour, and I promise I'm coming to the end. I'll just briefly summarize these points, because I don't want you to forget about these 5 issues. So if we think about genetic differences between population, I think those are unlikely to matter. GDP growth has mixed results. and maybe a bit more, stronger effects in high-income countries in the 20th century. But we also see that individual incomes matter, right? For nutrition, again, we have mixed results. We can see that it can explain some differences in stunting rates, but it doesn't seem to be a key driver in kind of decline in stunting. If we think about WASH, again, mixed results. Open defecation is obviously a very serious problem, but WASH interventions are not always effective, and it's not clear that they were effective in history either. We haven't tested that properly. It's something that we as historians need to work on. And finally, we have some mixed results for maternal health as well. It seems to be really important, a really important cause of child stunting in some low and middle income countries, but there are much smaller changes in Europe, North America, and Australasia. And so that's a puzzle. All right, so into the home stretch. What lessons can we learn from history? And I think there are kind of 3 points I want to bring out very briefly for you. One is that there are really large differences in these. I want to talk a little bit more about these large differences in maternal health that we've just talked about. I also want to talk a little bit about catch-up growth, and then finally a kind of view about generalized development. So beginning with maternal health and birth weight. Again, I've been over this. We know that there are these differences. And so what that means is that the interventions that led to stunting decline in Europe and North America may not be sufficient for some kind of low and middle income countries today. And that means that we need to really focus on gender inequality and sort that out. And this is, I'm not the first person to call on this. I think this historical evidence just bolsters this claim. And to give you a sense of how much this matters, I'm going to show you some birth weight trends in Japan, right? Because Japan is our country that has a really, really high stunting rate that declines entirely. So unfortunately, I don't have a graph that shows the whole trend, but imagine in your mind that the average birth weight in Japan in 1900 is around 2950 grams, okay? So somewhere down here. That suggests there's a huge increase of about 250 grams in the average birth weight of Japanese children between the early 20th century and the mid 20th century, okay? And so that may be how Japan was able to go from such a high level of stunting to eradicate it almost completely. That is the period in which Japan experienced its stunting decline. It's interesting then that average birth weights have declined so much in Japan, very puzzling. That is not related to gestational age or any kind of observable characteristics. That is a real decline. And it is associated with an increase in the share of women who are underweight from about 10% to 20% of Japanese women. So we can talk a bit more about that, but just an aside for now. The second lesson is about the first 1,000 days consensus. So this is a consensus that kind of exists around child stunting today. So because people see these growth faltering graphs, and we've seen this pattern repeated across the world, and because we also observe that under normal circumstances, children who become stunted remain stunted, the policy agenda has really focused on preventing stunting in these first 1,000 days. So what can we do to prevent these children from becoming stunted? And as a corollary to that, there's been this emphasis that after the first 1,000 days, there's nothing you can do, right? So the policy emphasis should really be on the first 1,000 days. And the historical perspective on this just does not support that, okay? And I'll give you the most striking example, which is the growth of enslaved children in the US South. And you can see that when they're kind of age 5, their average Z-score is about -3. So their stunting rate is well over 50%, probably 70%. But then as they age, they catch up. They move closer to the modern population. Again, the healthy population would be at 0 on this graph throughout, right? So they're approaching that healthy population. And the argument here is that once they enter the labor force, their masters start feeding them, giving them food properly. They get shoes, so they reduce their hookworm burden, and this allows them to experience this kind of catch-up growth. We see other examples of this, for instance, with work I've done on Japan in World War II, where Japanese children who are exposed to the kind of health shocks of the war actually experience catch-up growth later on. And so what this means is that catch-up growth is possible. We shouldn't rule out that this isn't something that can happen. You might argue then, well, maybe this is just about growth, right? But we know that stunting also matters for human capital outcomes. So can we extend that there? And there's a very small but growing literature on what's called double shocks. So this is if you have a health shock in early life, but then there's another intervention later on, does it mitigate the earlier shock? Okay? And what has been found is that if you have a health shock earlier on and then you have a kind of positive intervention, a school training program or some other kind of conditional cash transfer, you can actually mitigate the effects of that initial shock. So this isn't just something about growth. It could be also about other domains that we're interested in. And so how does this change policy priorities? I think the bottom line is that most stunted children do not experience interventions that would allow for catch-up growth, right? So that's not happening. So that means we need to continue to focus on preventing stunting in the first 1,000 days. That's important. I don't want to take away from that. But I do think we need further research on interventions that could mitigate the damage of stunting for the 148 million children who are stunted today, right? We don't want to just abandon those children. We should be doing research and policy experiments to try to help them out. All right, final point. I think in general, and certainly this is a wider critique of economics, I think that the path of economics that has gone forward, is that often current research is very, very focused on single policies or single interventions. And what I think we find for child stunting is that there's no silver bullet, right? These factors are context specific and they interact in really complex ways. And so we shouldn't be looking for the intervention that's going to make this happen. This is a process of generalized development. And if we think about Japan as an example of this, we can see that, right? So Japan experienced a very, very rapid decline in child stunting after World War II. The most rapid decline, except for North Korea, which you can decide whether you would believe that data or not. But very, very rapid decline. It's faster than Nepal, Ethiopia, and Peru, which are often held up as being like the countries that have done very, very well at eradicating stunting. But this reflects improvements in many broad indicators of development in the 1950s. So in the 1950s, GDP per capita grew in Japan at a rate of 8.2% per year. Life expectancy increased by 8 years. The diet diversified to include a lot more sources of animal protein. So there's not a single cause here. There's a generalized program of development which allows stunting to be eradicated and kind of allows for these interactions to occur. And finally, I think this kind of generalized development approach also points toward less tangible factors, right? Things like attitudes toward health and hygiene, and demand for public health provision from people of their governments. And I'll end with this kind of anecdote about the Rockefeller Foundation. So the way I told the story before, they arrived in Jamaica, they built a bunch of latrines, and everybody was better off. But that's not the only thing they did, right? They also went around with microscopes and showed people what hookworms look like, right? And what bacteria look like. And they convinced them that they had agency in their health, right? And they could make a difference. If you think about another part of the world, in West Africa, where the French were doing sleeping sickness treatments that led to huge levels of mistrust, like this is a very different program, a different way of doing colonial medicine, right? And so it's that change in attitudes, and Riley really mentions this in his book, that really matters for kind of promoting better health. And so I think research and policy makers shouldn't lose sight of this bigger picture. Thank you. And sorry, one shameless plug. If you want to learn more about this stuff, I did just recently publish a paper, open access, in the Journal of Economic Surveys, which goes into a lot more detail. So if you want to get more into the nuts and bolts, then take a look. Sorry, I'll pass over to you.
Thank you, Eric. Sit down. Take a second. We now have about 20 minutes for questions and comments. Great to see some hands rising. Let me just remind those of you who are joining online, which I believe includes your parents.
Yeah, well, yeah. See, I think so.
So any amusing anecdotes they want to feed in, more than welcome. But if you wish to ask questions, please put them into the system, and they will appear before me, and I can voice your questions for you. So thank you. But I can see some questions. But can I just start very quickly? Could you say a little bit more about the consequences of stunting for these children? I mean, you mentioned it in passing, but how serious an impact does it have on a child's development to fall into that group, which is a very, very substantial group in some countries who are experiencing stunting?
Yeah, I mean, it is a big effect, right? So, we're talking about years of education that are lost. And a lot of it has to do with productivity as well. So I think the thing that we don't always think about is that, when a child is sitting in a classroom, their health is going to affect how well they learn, right? If you're really tired or, if you're, sick, you're not going to learn as well as if you're not. And so the fact that the disease environment affects stunting so much and stunting is reflected in the disease environment, I think really then, it makes a big difference for these educational outcomes. There's also kind of other effects on later life health, especially. There's a kind of Barker hypothesis that or the fetal origins hypothesis that conditions in early life, basically lead to poor outcomes later on in terms of higher rates of diabetes and cardiovascular diseases. So there are those effects as well.
So it's really kind of a very rounded package.
Yeah.
It's really interesting to hear that. I've got a number of hands already. I'm going to start with Safia first, and then I'll move on around that.
Thank you very much, Eric. This was really fascinating to watch the entire presentation. My question is really about looking at cultural differences within countries. So I'm thinking in India, you have, a large Hindu population who will not eat meat. Whereas you'll also have, a Muslim population that is going to eat meat, and nutritional value of meat, protein, all that kind of thing is going to impact people's health. So even in thinking in terms of the differences between India and Pakistan, maybe, with regards to how this can impact health, how do you take that into account in your research? And are you concerned about differences and changes of shares in populations over time?
Yeah, I mean, when we are aggregating kind of national stunting rates, we weight things based on the population as best we can. This is a tricky question. Stunting rates are lower among Muslims than Hindus in India. So that reflects your kind of vegetarianism versus meat eating. There's other evidence, though, which is one of the things I didn't talk about, one of the causes, about household resource allocation. So there's a paper by Seema Jayachandran and Rohini Pandey, which argues that in Hindu families, they tend to favor the oldest son to the detriment of all other children, not just girls, but all the male children as well. And that creates a kind of sharper decline or a kind of sharper birth order effect in stunting than you see among Muslim countries, among Muslim Indian people. That's been challenged. I think, it's problematic. There's data issues there that are quite technical and maybe not that interesting, but very important. So I'm not sure I'm really convinced by that kind of argument anymore. But there are clear differences among groups in that way. So then it's kind of a matter of is it that Muslims live in different areas? Do they eat different foods? What are these different factors that matter? And how open are they to changing their behavior if that's what's needed? So yeah, I don't know if that answers your question, but some thoughts about that.
As a younger son, I have some sympathy. Next question is here from Kent.
Thank you, Eric. Excellent presentation. I'm always interested in your findings. My question is very simple. Among all these factors, variables like GDP, like body weight, can education level play a role if people think, normally we think tall people are cool. Yeah? So if you are informed, so parents may do something if they are better educated. They will fit their children better. So I wonder whether human knowledge or reliable knowledge play a role. Thank you.
Yeah, I mean, it's a really good question. I think the answer is probably yes. It's very difficult to test that, though, right? Because people who are educated tend to be richer and live. So there's just a lot of it's kind of difficult then to get a clean test on this, right? We'd have to do what Neil Cummins, one of our colleagues, does and try to look at some kind of exogenous change in policy related to education and see how that would affect these types of outcomes. I I think it probably also makes more difference for mother's education or father, parents' education rather than the children's education. Although an important part of changes in the diet are related to school meals programs, which are rolled out in many countries around the world and are really important in India in reducing stunting, also potentially in Japan, although it hasn't been tested properly, and potentially in the UK as well. So going to school also means you get an extra meal. That's probably a high quality meal that may help you grow and be healthier.
Cool. Let's come to Jane here on the second row, and then we'll go to the back to Oliver.
Yes, thank you. That was absolutely wonderful, Eric. I wanted to ask about something that you didn't mention, probably because it's not important, but I'm interested in emotional trauma and stunting. And I remember in one of Roderick Flood's early books, there's a graph where he shows one of those famous children who was murdered, even though she was known to be at risk and so on. And he shows a graph of her heights and weights when she's taken into care and then given back to her family, then taken into care again. And you can see this relationship of how when she was returned to her parents, she fell away from the normal growth trajectories. And I'm wondering, can you actually generalize that individual experience to the trauma, particularly as we see what's happening in Gaza, we see what's happening, in Ukraine, that even if we can remedy the physical effects for children who've lived through these events, what about the trauma that they've experienced? And does that actually affect children's growth?
Yeah, I mean, I think that's also probably something that matters. There's recent research on postpartum depression and how that affects child growth in low and middle income countries, and it shows an effect. It's again difficult though, because people who experience postpartum depression are maybe not a random sample of the population, and we also know from our the experience of high income countries that postpartum depression doesn't lead to child stunting in the UK or in Europe or in any country that's eradicated stunting. And so I think this is one of those places where you have these interactions, right? Where, where resources are scarce, these things matter a lot more than where resources are plentiful. Speaking directly to trauma, though, I also have a graph like that, which is in one of my papers that shows this boy who was living in the Marcella Street home, which was a home for kind of poor children in Boston, Massachusetts. And you can see that when he's in the home, he gains weight. And when he's outside the home, he always loses weight, right? And you can see there's catch-up growth as well in terms of height in the home, and then he falls behind outside of the home. So maybe that's speaking a bit to trauma, but in a kind of different way. And because I think the way that we would think about institutions today is that they would be places of trauma, right? Rather than home life being a place of trauma. And so I think that's a difficulty there is like,
That's like Oxford's finding about prison.
Yeah, no, absolutely. So that's a tricky thing to kind of, and again, like we're dealing in a place where we're we have a situation here where we can't run experiments. We can't like abuse a child and see what happens to them.
I don't think you'd get that as an experiment even today.
No, so it's very difficult to then unpack these things, right? Because they're always tied to a million other factors. And so how do you separate the trauma from, the lack of, other issues, poverty and, poor locations, things like that.
Oh, brilliant. The wonders of social science. Oliver, let's go back to Oliver. I've got a long list, so those of you I'm not picking on, it's nothing personal. I'm going to work around it.
Eric, yes, thank you. That was wonderful. And not just what you presented, but also how you presented it. If I remember your graphs correctly, I think there was a slight increase in stunting in high-income countries in recent years, not just in the UK, where this seems to have been going on since the 1990s, but also elsewhere. And I think there was also something in the papers about a couple of months ago or on that topic. So, is that linked, or is that, basically the same phenomenon that we observe in Japan with the decline in the weight at birth over the last few decades, or is that something else? What's going on there?
Yeah, I mean, I've got to remember now. Birth weights have fallen a little bit in the United States. My recollection is that they haven't fallen in the UK, but I may be wrong about that because I can't remember exactly. So I don't think so. I mean, the papers, when they had that study come out, they put it down to austerity, right? So David Cameron is back, so we know who to blame maybe. Yeah, I mean, it reflects a similar process in that, like, the material conditions of life affect children's growth, and we're seeing that even today. Even though, we've got to the point where we're not in a place where there's, huge levels of deprivation on an absolute scale, there's still, changes in a relative way that are intriguing and important to keep track of. So yeah, I mean, I think we should continue to do these studies, and it's important to track children's growth today.
Let's come down here to Melanie, if we could, in the front row. Thank you. And then after that, we'll go over to Jordan, who's been waiting very patiently.
Thanks, Eric. So I think it was a really, really nice talk. So I got to learn about this all systematically. So I do have some questions. One is about the role of the genetics. Mm-hmm. I mean, I think you downplay this for obvious reason because, I mean, it's not an area you can do too much intervention. But I do wonder, because I never knew about the Caribbean low prevalence of stunting. But when I heard this, I do just thinking about the population makeup. Do you think there might be a relationship between the unusually low stunting rate there and the earlier selection in when the slaves were transported from Africa? Obviously, they had a very high mortality rate, and then probably did have some selections. So that's one question. But then kind of related to this, so about the gene, I guess the gene environment interaction. So what do you think about it? Say there are, it's not just the persistence in diets, but also inside of us, there are different mechanisms of absorbing those macronutrients that have been shown that is highly persistent. So there might be a limit to how much you can do that kind of intervention when there are a clear resistance from the body. So I think I will ask other questions later, but those are just things that came out from your talk, and I just would be curious to know. Yeah.
Yeah, thanks, Melanie. Yeah, I mean, it's hard. The selection in the Caribbean, it's an argument that's made. I'm skeptical because the stunting rates were very high, in the early 19th century. And the other thing that I found in other work that I've been doing is that, mortality isn't very selective when it comes to height. Deaton has a paper where he argues basically that, the shortest are more likely to die, and therefore you have a kind of upward bias in heights through survival bias. And where I can track that in the Foundling Hospital, which I can track, I can look at birth weights and who dies, I can look at weight in infancy and see who dies. You see that the deaths are drawn from across the distribution there's a slight difference in, the deaths are way slightly less than the people who survive, but not a huge amount, right? And so it can't really explain kind of these big drivers. Now that's a completely different historical episode, right? That it's a kind of level of torture that, normal people aren't exposed to. So it's difficult to know, how that would, but then again, I wouldn't necessarily go to innate causes there. Whether someone was fully fit when they first departed for the coast versus whether they've been on the ship for a number of weeks might matter more than their genetic potential or their genetic frailty. It's hard to know. In terms of gene-environment interactions, I mean, there are gene-environment interactions, and they're also really difficult to test. So these genome-wide association studies, they focus on the genome, and that's because we can look at the genome, right? We can measure it. We don't have a kind of similar way of measuring epigenetics, right? Which is the processes that control which genes are expressed or not, right? And so until we can do that, it's very difficult to understand how those things are working and how they're changing over time. Yeah, that's almost impossible, I think. So I did have a conversation once with Mark Hansen, who kind of was doing a lot of work on the fetal origins hypothesis about whether you could go back and find blood smears from the 50s and then extract, genetic information from them and try to look at changes in that way. But that's very challenging, obviously. And especially to get the kind of large samples that you would want to do these kind of massive, massive studies. So I hope that answers your question.
I'm seeing a major grant application there. Let's come over to Jordan there, and I think we're coming close to time.
All right. Thank you. This is perhaps an unfair question because I'm going to ask you about something you didn't talk about, but that I maybe would have expected that you know something about. And that's about, I asked this question less as a medievalist and more as a relatively new parent. But I didn't hear breastfeeding as a large part of your narrative. And, when we were having a baby and we kind of did the North London NCT thing, it basically is like hammered home in a lot of ways that if you can't breastfeed, you have somehow, failed or given. But then you told the story about William and like the breastfeeding might have been more impactful the further you go back in history. So, but I didn't see any controls for that kind of stuff or anything. So I just wonder if you can talk a bit about the role or not of that in this stunting story.
Yeah, no, thanks. So I actually have a paper on the Foundling Hospital looking at breastfeeding and the effects of breastfeeding on health. And we do find that there's an effect on weight. So all children experience growth faltering in weight, but exclusively breastfed children do better than children who were, supplemented or who were never breastfed, who do the worst. And we can actually, the Foundling Hospital, it says next to the child's name, it has like B, M, or F, or any combination of those. So you actually know, are they getting milk? Are they getting food? Are they being breastfed? And then sometimes it will tell you how many months they were breastfed for, or weeks. And so what we find is that actually milk is the worst thing. Giving children milk, makes them the worst off. We find that there are lasting effects on health in that, so we can only measure the mortality of children after they enter the Foundling Hospital. So that's after they've been weaned, because all children were weaned once they entered the Foundling Hospital. What we see there is that actually children who are exclusively breastfed or breastfed at all have lower mortality risk than children, even after they are no longer being breastfed. So there's some kind of carry-on effect there. So we see some effects, I guess. We don't see any effects once they get to age 5, though. There's no lasting effect, right? And that's actually matches a lot of literature in developing economies that, like breastfeeding is about, especially in low and middle income countries, is about preventing child deaths, right? By, preventing children from being exposed to pathogens that will hurt them. But it doesn't really affect stunting. And like breastfeeding interventions don't have any effect on stunting where they've been done. Although breastfeeding is also not randomly assigned. So that's another problem there. But, that's kind of the best of what we know, I think.
I'm going to actually take a question from online. Unfortunately, we had a little bit of a technical hitch where I wasn't getting the questions from online. So those of you who've been patiently watching and wondering where your questions are, they were over there, not over here. But there's one question I feel we have to ask, because I think it tells us in itself something about where this research strand came from. Eric has an identical twin brother, Tom, who is 170 centimeters, whereas Eric is 178 centimeters. What areas in epigenetics, given that hundreds of genes affect height, do you think should be further affected? And that was from Mark Schneider.
Yes. So this is true. Interestingly, I weighed less at birth than my identical twin brother.
Catch up.
So yeah, there's some catch up there. My identical twin brother is also allergic to milk, and I'm not. And so that could potentially be part of the explanation. So those are the kinds of things. And I think that actually in itself shows the kind of plasticity that I was speaking to. Like we literally have the exact same genes, and yet there's enough, variation there that there is variation within twins. So to me, that speaks to the importance of plasticity rather than, your genes are not your fate. And so therefore, now what exactly the pathways are, it's difficult to know. And, partly I thought about opening with a discussion of that as a kind of nice anecdote.
It would have been a good photograph.
Yeah, it could have been a nice photograph. I don't want to shame my brother for his faults. He's going to watch this. He's not watching right now, but he will, I think. But also I wanted to kind of move the focus away from individuals, right? Because what I'm really interested in here is differences in populations, not, again, like if you remember that graph, there are short and tall people, right? And like if one person is short and another person is tall, a short person isn't necessarily unhealthy, right? We don't know that, right? It's only by comparing populations that we can then understand that a bit more. Now, if someone is 3 standard deviations below the mean, the probability that they're unhealthy is higher than if they're at the mean, but still we don't know for certain.
Thank you. I think we're going to have to close there. We are at time, but before I invite you to thank Eric once more, I just want to say a couple of things. Firstly, obviously, you've done a tremendous job in demonstrating exactly why your work is so impressive, and this was very much kind of showing us what the frontier looks like. It was, I think, absolutely fabulous. We have another opportunity next week for those of you around to come and hear a different speaker from the department with Mary Morgan's lecture on how economics changes the world. This is to this is part of Mary's year as President of the Royal Economic Society. We're very proud to have the President of the UK's main economics society in the department. But that's for next Thursday. This is this Thursday. And we are very happy, and I'd like everyone to thank Eric very much for a fantastic lecture and a wonderful discussion. Eric, thank you so much.